Welcome back. Today we have the fourth and the last solution for the jump game problem. The problem says you are given an integer array called nums. You are initially positioned at the array's first index, and each element is in the array represents your maximum jump length at the position. Return true if you can reach the last index, or false otherwise. For example, we have this one example. We return true because we can reach the end here. From 2 we can jump 1 step, and right directly you can jump 3 steps to 4. Here we can't reach to the end because you will always arrive at index 3, which is 0 no matter what. Its maximum jump length is 0, which makes it impossible to reach the last index. And there is a lot of solutions that we have described before, and we wanna represent a greedy algorithm, which is the greedy algorithm. Basically, it's a greedy algorithm is it's a paradigm that follows the problem solving of making the locally optimal choice to each stage with the hope of finding a global optimum. In simpler terms, a greedy algorithm makes the best choice at each step without considering the entire problem. And this is what we want to do. The problem we will have, it will be like 5 lines of code. It will not be long. It will be easy also to represent. So say we will have a last spot, last pause or let spot variable, and this one will be nums.length -1, and here we basically start from the end and try to see if we can reach the beginning or not. So I will create a for loop, and I will say let I equals nums dot length, okay, -1. I should be bigger than or equal 0, and I will be minus, and I will say here if I plus nums of I nums of I bigger than or equal last pause, that means we can reach the end. So we can reach this specific point or last point. We will update the last point will equals I, and after that we will return if last pause equals to 0 or what, because if it's equal to 0, that means we are reached the beginning, and that means that we can reach the end. So let's just try to explain the code here. The code starts by initializing last pause to the last index of the array, and this represents the initial assumption that you can reach the end from the last position. The loop that you can see iterates through the array in reverse order, starting from the second to last element on the moving towards the beginning of the array. For each position I, it checks if you can reach or go beyond the last pause from that position. I plus nums of I bigger than or equals last pause. If this condition is met, it means that you can potentially reach the end of the array from position I. If the condition is met, it updates last pause to I, effectively moving the reference point for the farthest position that can reach the end. After the loop completes, if last pause is equal to 0, it means that you can reach the end of the array from the initial position, index of 0. and then functional returns true, otherwise it returns false, indicating that it's not possible to reach the end. So let's try. We tried with this one, let's give an example to make sure that if you understand it or not. So last pause will be here, nums.length -1, and it will be 1 2 3 5, so it will be 4. And let's talk about nums of I. Okay, so we start first with last pause. Let's submit first and see if it work or not. Okay, it work. And let's go to the code. So here we start here. We say that okay, we have the last pause, it will equals 4, nums of I will equals nums I minus 1. So it will be nums of I will equals 4 also, because we already at the end. And we have here I equals 4. Everything equals 4 from the beginning. Oh, that's weird. 0 1 2 3 4. Yeah, it's equals 4. So we say that if I if I plus nums of I bigger than last pause, and that's true because I is 4 and nums of I is 4 and last pause is also 4. So yeah, it is bigger than it, so last pause will be equals to I, which will be equals to still 4, and right now I will be 3 and 4 will be so nums of I will be equals 1. And I'm saying okay, if I, which is 3, because I wanna know from this position could I reach the end or not, because of that I put I. I'll say I plus nums of I, so I is 3, nums of I is 1, is bigger than or equal last pause, it's equals to 4, so yeah, it's equals to it. So last pause will equals I, so last pause will equals 3 right now, and I will equals 2, and nums of I will equals what nums of I will equals? Nums of I will equals 1, still 1. So I'm saying okay, does I plus nums of I bigger than or equal last pause? Last pause is 3, and these plus each other will equal 3, so that's true. So our last pause will equals I, so it equals 2, and we update and we loop again, so I will equals 1, and nums of I will equals 3. And I will say okay, if I and nums of I bigger than or equal last pause, actually they are bigger because it's 4 and last pause is 2, so I will last pause will equals 1, it equals I big right now, and I would take 0 from I, and right now nums of I equals 2. So I'm saying that if nums of I plus I, which equals 2, bigger than last pause, which is 1, that's true. So last pause will equals to 0, and the loop ends because I is bigger than 0. And when we check if last pause equals to 0, this is return a true or false, and if it's true, that means we can reach there, false we can't. And because of 0, that means we successfully reach the end. And yeah, that's it. That's it for today's video, and the home description is quite good. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss a video, and see you in future problems.